here. Sometimes it's hard to get out of a previous session immediately. And but anyway, I can go 5 minutes long if you need me to. All right, I have the 3 files you sent me yesterday. Which one do you want me to open?
I actually did end up finishing those, so I have more to send you.
Okay. Have you added phase shift and vertical shift yet?
Have I what?
Have they added phase shift into your...
No, they have not.
Okay. So they're still leaving it relatively straightforward with just a amplitude and a period change, huh?
Yeah.
The phase shift and the vertical shift really don't make it that much harder. You got to do 4 things instead of 2. But, you know, you do them one at a time anyway, so.
All right. I'm about to send them.
Okay.
All right, the first one's sent. Second one's sent. And the third one's sent.
Is that the order you want to look at them?
Yeah.
Let's have a look at this for a minute. Okay, we're graphing just straight y equal cosine of x.
Yep.
Clearly identify the key points from minus 2 pi to 2 pi. So we can start there, although it's probably easier to start at the origin, merely because that's where I usually start.
Yeah.
It's not often that I start at minus 2 pi, but we can start at the origin and work our way backwards. Where do I start at the origin? What is the cosine of 0?
It's going to be 1.
Okay. The key points?
It's going to be pi over 2, and then 3 pi over.
And negative of each of those. Okay, so I know that it's there is 1 point. And I know at the first quarter point, it's down on the x-intercept. The second quarter point, it's right there. Third quarter point, back through the x-axis. Fourth quarter point to there. And that looks like this. And then I do exactly the same, only opposite on the other side. Okay? Well, this is kind of interesting. I did find a nice, easy way to memorize something that I was thinking about it after our session last night. And that's that the tangent straddles the y-axis, so does the secant. Whereas the cotangent and the cosecant sit next to the y-axis. And by that I mean tangent straddles the y-axis with a period of pi, so it's got to go from minus pi over 2 to plus pi over 2. Cotangent sits on the right. Cotangent, I have a vertical asymptote there, and it's always decreasing, so it looks like that. And secant sits there, and cosecant sits there. So that's one way to remember it, is that the cos, not the cosine, but the cotangent and the cosecant sit immediately to the right of the y-axis, whereas the tangent and the secant straddle the y-axis. And the reason I realized that I needed that was because I was tired of always having to base it off the sine and the cosine. And I was looking for a way to memorize it on its own. And that's a good way. In other words, now for me to graph the secant, I know that it has to be here, which makes the other side of the period there. All right, cotangent of y. How do I graph that?
Cotangent of y.
X. I'm sorry, cotangent of x from minus 2 pi to plus.
The cotangent will be going from
Start with the asymptotes. Where do my asymptotes go? Vertical asymptotes. Because once you have the asymptotes, then you can draw the function in between them. But you need to know where the asymptotes go.
I do not know where the asymptotes are.
Well, they go to the right of the y-axis. Remember what I just said, that this is cotangent. In other words, if it was tangent, they go around the y-axis. But since it's cotangent, key being co, then the vertical asymptotes go there, there, and there, and there. Every pi, you have a vertical asymptote with tangent or cotangent. In fact, with secant and cosecant. All vertical asymptotes on 4 of the 6 trig functions are separated by pi, but different pi's. In other words, if I was drawing the tangent, it's actually the asymptotes go right here and here. In other words, shifted. But this is for cotangent. So now how do I draw the cotangent within each set of vertical asymptotes?
Doesn't matter. We'll start one at -1 and it'll go.
It doesn't start at -1, it starts at positive infinity. And it comes down, goes through halfway between the asymptotes, like that. In other words, it looks very similar to the reflection of tangent. And the next one does the same thing. And there's one more. And I didn't draw that vertical asymptote out. I needed to. So the key really is placing your vertical asymptotes.
Okay.
And I see they have some questions over here. What's the domain on this?
Which one? One or two?
2. We'll finish 2 and then we'll go back to 1.
The domain is all reals except multiples of pi.
So X is a member of all reals except what?
Multiples of pi.
Like that. Did you find out if that's the appropriate way to state that? In pi?
You don't need the n in there. You can just say multiples of pi.
Oh, so she doesn't, okay. So she's allowing the verbal response.
Yeah.
Multiples of pi. Good, I like that. Okay. What's the range?
Negative infinity to infinity.
And is that odd or even?
I think odd.
It's neither. Odd means symmetrical with the origin. An example of odd would be sine. Sine goes like this, and by symmetrical with the origin, I mean if I flip this about the y-axis and then the x-axis, I would be looking at this. And that's what sine does. In other words, right there is your symmetry about the origin. So sine is odd. Cosine is even. Notice that cosine has perfect symmetry about the y-axis. And that's why the cosine of minus x is equal to the cosine of x, which is characteristic of an even function. So cosine is even, sine is odd, their reciprocals are the same, but tangent and cotangent, well, first of all, that's not, well, let's see. If I was going to make that even, then it would have to also look like this. That would be even function. And it certainly didn't look like that. Now, let's see. If I flip that thing over the x-axis and then over the y-axis, gosh, maybe it is. I never realized this. Let's see. Let's flip it over the y-axis first. And then flip that over the x-axis. It is odd. In other words, what I get when I do that is that. And that's what it looks like, is it just repeats. In other words, that is symmetrical about the origin, which makes it odd. I thought it was odd that they didn't have a neither. I didn't realize that. All 6 trig functions are either even or odd. They are not neither. Unless, of course, you change it. In other words, if I phase shift the sine curve and start it there, now it's not even anymore. Notice that it no longer is symmetrical with the origin. So it's only the unshifted ones that are either always even or always odd. Cosine domain,
All reals.
range,
-1, 1.
asymptotes.
Are they every pi?
No, this is cosine.
Every pi over 2.
Never. There are no asymptotes. In other words, x can be anything I want. Same with sine. It's only the other 4 trig functions that have asymptotes.
Okay.
Period of the cosine is how much?
2 pi.
Odd or even?
Even.
Period of cotangent?
Pi.
Cosecant. Where my asymptotes go?
They go every pi over 2.
Remember what I said about cosecant? The secant straddles the y-axis, but the cosecant sits next to it. So the cosecant looks kind of like that.
Mm-hmm.
So the asymptotes?
Every pi.
You know, the first one goes there, and they alternate. Domain?
Hold on just 1 second.
Mm-hmm.
Domain is all reals except multiples of pi.
Okay. Range?
Y is less than or equal to -1, and y is greater than or equal to 1.
Period?
Hold on. Period is pi.
Remember, the period is where it begins to where it begins again. So from there to there is the period.
It'll be 2 pi then.
2 pi. Remember, it's 2 pi for everything but tangent and cotangent. They have periods of pi. But sine, cosine, secant, and cosecant are all 2 pi. Even, odd?
Odd.
Symmetrical with the origin. Okay. Let's see. That was the first one. Let me pull
The next page is the same thing again, except it does the other 3.
Oh, really? Okay. We have one for each. We should be able to knock those out pretty quick. Kind of like that, rather than giving you the phase shifted, or rather like the ones yesterday. It's really good to have a basic understanding of the elementary function. Where's secant of x's asymptotes?
So these ones are every pi over 2.
Yeah. Because you know that that first thing has to fit in pi. And this one's 3 pi over 2. And that one's minus 3 pi over 2. And I said it's straddled. So it's got to go there, there, here. But that doesn't complete the graph. between minus 2 pi and pi. So I don't have another asymptote to show you, but I still have to put minus 2 pi there, and I got to draw half of it. And I got to put 2 pi over here, and I got to draw half of that one. Like that.
Okay.
Jackson, you need to get some sleep, buddy.
I know.
Okay, the domain.
Domain will be all reals except multiples of pi over 2.
I think it's odd multiples of pi over 2.
Oh, yeah.
Because it's a pi over 2 and then a 3 pi over 2 and a 5 pi over 2. So, okay. Range.
Y is less than or equal to negative 1. Y is greater than or equal to 1.
Asymptotes, we did those already. Period.
This is 2 pi over 2, right?
No, 2 pi. Remember, everything's 2
Yeah,
pi
yeah,
except tangent or cotangent, which is pi. But the period goes from here to there. Don't make the mistake of thinking that's one period. It's that one combined with this one down here that make it one period.
Okay.
Okay? And I mean, going from minus pi over 2 to 3 pi over 2 is 2 pi. So, odd, even?
Even.
For some reason, I have a terrible time drawing the other. I can never get it to be quite right. It's like all of a sudden I'm trying to draw left-handed. When I go to the left of the y-axis, it's bizarre. But, okay, so this point is 2 pi. This point's minus 2 pi. Domain?
All real numbers.
Range?
Negative 1, comma 1.
Asymptotes?
None.
Period?
2 pi.
Even or odd?
Odd.
Tan of x. Asymptotes. Remember what I said about tan and secant?
Yeah, every pi over 2.
Tan and secant both straddle the y-axis, which means I need these kind of asymptotes. It means I don't have an asymptote on the y-axis. And since it's got a period of pi, in order to straddle that, I got to go from minus pi over 2 to pi over 2, like that. And again, I'm going to have asymptotes at the 3 pi over 2 and the minus 3 pi over 2. And it's going to look like this. In other words, since the total length of the x-axis is 4 pi, I should have 4 curves in there. And I do, except the last two look like this. In other words, just the upper half of this one and the lower half of that one. Because this is 2 pi here. Domain?
This is going to be odd, right?
Odd multiples of pi over 2, correct. for the asymptotes?
Yeah.
Because they come at 1 pi over 2, 3 pi over 2, 5 pi over 2. Range? So the domain was all reals except for odd multiples of pi over 2.
Yeah.
Range?
Negative infinity to infinity.
Asymptotes are odd multiples of pi over 2. Period?
Pi.
Even, odd?
Odd.
Uh-huh. I know, you're staying up late doing too much homework, right?
Yeah.
You guys aren't as lucky as Douglas County. They're on
Why is that?
fall break. I
I
know.
wish we had fall break.
I'll bet. Let's see.
How long is there? A week?
A week, yeah.
Is it right now?
Uh-huh. It is. Just a second. I think I dragged this and dropped it to a bad spot. Let me drop it there. Ah.
Yeah, we don't have another day off of school unless we have a snow day until Thanksgiving break.
But you guys get a bigger Thanksgiving break than Douglas County does. I'm not sure how much bigger. Do you get a whole week off for Thanksgiving?
Yeah.
See, I think they only get 2 days.
Oh, that sucks.
Even still, their 7 days is longer than your 5 days, I guess. Is this
Yep.
same thing, same question? We just did this question. And we had to give the domain of tan x. What was it?
Domain of tangent is pi, or all reals except for odd multiples of pi over 2.
Yeah. Now I wonder if they're trying to be tricky here, because they say give the domain for that. Well, obviously it's not all reals. It's only from minus 2 pi to 2 pi. In other words, this is slightly different. I think, I noticed on the previous page it said graph it from that interval, from minus 2 pi to 2 pi, and then it asked about domain. And I didn't know whether the domain should be restricted to that. But for this one here, it's definitely to be restricted to that. So it's not all reals. It's minus 2 pi to 2 pi with the exception of odd multiples of pi over 2. I think. I'm not 100% sure, but given the way the wording is, I don't know what else it could be. Give the range of tangent x from 0 to pi over 4. There's pi over 4.
It would still be negative infinity to infinity, right?
No. What's the tan of pi over 4? Remember pi over 4 is 45 degrees?
Uh-huh.
And I said there should always be a mark there, and very few people put it on there. And I've never understood why, because it's actually a very key mark. It's where the tangent is equal to 1. So what's the range between 0 and pi over 4 for tan?
Would it be 1?
0 to 1.
0 to 1?
Yeah, because it can be 0 here. It could be like a tenth there. It doesn't reach 1 until it gets to pi over 4, so it can be anything from 0 to 1. Remember, when you're reading range, you're reading the y coordinate of that curve. So what's the range of tangent between 0 and pi over 2?
Well, this one doesn't have less than or equal to. This one just has less than and then greater than.
That's true. Okay, so what's the range? I didn't even notice that, but that's a good point. Ooh, plus they really get tricky and make that less than pi over 2 instead of less than or equal.
Yeah.
Ooh, that's interesting, because I don't know. I think that maybe changes the answer.
Yeah, I'm not sure.
When you study calculus, well, what's the range between 0 and pi over 2 that you can read from the graph?
It'd be 0 to...
Infinity, right?
Yeah.
Okay. Well, if I want to put that in interval notation, I'm going to put it like this. But since it can never be pi over 2, yeah, no, that's correct. I think whether that's less than or equal to, I don't think it affects the range. Although I'm not 100% sure about that. You wouldn't be able to put an upper limit on that if it was any number other than infinity, so it's got to be infinity. It's kind of like, does the limit exist sometimes? You'll learn all about it in calculus. You're junior, right?
Yeah.
You taking calc next year?
I think I'm actually leaning towards stat for the track I want to go down in college. Stat will be more of use to me.
Okay. What are you going to study in college?
Thinking about something in the field of like sports science or physical therapy.
Okay. Yeah, you're probably right. I was going to say, if you're going to go into any kind of science or technology field, you'd want the calculus. But in sports, you might be right. The statistics might be more valuable. All right. Amplitude and period. It's the amplitude of secant x.
1.
Period?
Pi, or 2 pi.
Okay. It's the amplitude of this.
3.
The period?
2 pi over 2. Or just pi.
2 pi over 1/2. Remember, b is 1/2.
Yeah. So then that would then be 4 pi, yeah.
4 pi. Whenever the coefficient of x is less than 1, it has the effect of lengthening the period. If it's greater than 1, it has the effect of shortening the period. In other words, the period of that is pi, not 2 pi.
Okay.
Amplitude is 4. What's the period?
It'll be 6. Hold on.
Remember, it's the tangent function, so it's going to be pi divided by b, not 2 pi divided by b. Okay, for tangent only.
It'd be 3.
Right. Pi divided by pi over 3, that's equal to 3. Anything special about this grid? No. Other than the fact it goes from 1 to 4 instead of 0 to 2 pi. These are radians. So let's do 4 sine of 2 pi x.
So the period's going to be 1 for 4 sine 2 pi x.
Okay.
And it'll start at 0, 0 because it's sine.
Okay.
So, and since it's positive, it'll start up.
Okay. Where does it end? Where does the one period of it end?
at 4.
No, you just said what the period was.
Yeah, at 1.
Okay, so it's got to end there. So I got to quarter that from 0 to 1. And I got to start, and I got to get to that point. I got to come back down through this point. I got to go all the way down to -4 by this quarter point, and I got to come back up to my start at that quarter point. So repeat 4 times. Okay?
Okay.
And do I have to do that, or I don't see the purpose of me testing my art skills like that? Okay, so that's all there is to that one. And the other one, they want us to put on the same axis. What's the period of the other one?
1 as well.
And its amplitude is 4 as well, so where does it go?
It'll start on the +4 and go down, right?
Remember that it sits on top of the peaks and the bottom of the peaks. So it's got to do something like this. And its asymptote, its asymptote's going to come wherever sine is equal to 0, which is right there, right here, again here. So the other half of the period for this function is down here. There is one period of both functions plotted. And take this and repeat 4 times. Now let's do these one at a time here. Amplitude. First of all, it looks like a what kind of curve?
Hold on just 1 second. Alright, for 5?
Yeah.
The amplitude will be 2.
Okay.
It looks like a cosine curve.
Negative cosine curve, maybe?
Yeah, negative cosine.
Okay, and what's the period that we're looking at here?
Looks like 0.5.
Uh-huh. So what is B?
2 pi over 0.5.
Equals?
-2 cosine 2 pi over 0.5.
Well, simplify that. That's 4 pi.
Oh, yeah.
Okay, so it's cosine of 4 pi x.
This looks like a positive sine graph. The period looks to be 4. So B would be pi over 2.
It's positive sine, so it's 4 sine pi over 2x.
5 sine pi over 2x.
Oh, 5, yeah. Yeah, the amplitude was 5. Why does that bother me? Let's see. Let's see. Period is 4. Period is 2 pi over No, I'm sorry. B, isn't B 2 pi over 4?
Yeah, be 2 pi over
Oh,
4.
that's pi over 2. What am I thinking? Yeah. Gosh. Been a long day.
Alright, now we can go back to the other files that we were doing yesterday. And
Okay, well, there were some early ones that we didn't finish, I think. I don't think we did these. Should we do these?
Yeah.
Okay, what's number 5?
Number 5 looks like a cotangent graph.
It's increasing, but you're right, it does look like a cotangent graph. No, it looks like a negative cotangent graph. Because it's not straddling the y-axis. So it's not tangent. It's next to the y-axis. So it's cotangent, but it's increasing, so it has to be negative cotangent. What's B? What's the period?
B is 1/4, but the period will be...
We can read the period from the curve. What's the period? We don't know what B is yet.
It'll be 2 pi.
Okay, so the period equals 2 pi. B equals what divided by the period?
Pi divided by 2 pi.
So the period is 1/2. Remember that numbers less than 1 have the effect of stretching out the period, and this is twice the normal period. In other words, the normal negative cotangent would be have a period of pi.
Okay.
And do we need to do domain and range?
No.
Well, let's just do domain. Make sure you state it right.
X is all reals, except multiples, or no, it'd be odd multiples of pi.
Even multiples of pi.
Oh, I'm looking at the wrong thing, sorry. Yeah, even multiples of pi.
Okay. Or I suppose you could say multiples of 2 pi. All right, let's look at 6. Oh. What kind of curve is this?
Cosine.
Positive cosine, okay. The period from the graph is...
The period is...
Go from any two equal points on the graph. In other words, they don't let us go from here to here because they don't show that part. But I could go, and going from there to there, they don't label that part. So the only part they label is this one and this one. That is one full period. In other words, when you go from trough to trough or peak to peak, you're going a period.
Okay.
So what's the period?
2 pi over 4.
So B is what?
B is 4 pi, no, 4.
Okay. And numbers greater than 1 have the effect of horizontally squeezing it. Okay, what graph are we looking at there? First of all, we should be able to isolate it as either cotangent or negative tangent. What is it?
Negative tangent.
Good. Okay. Notice the amplitude is 2 because at the halfway point it's 2 where it normally would be 1. In other words, in the normal curve, this point comes at 1.
Okay.
Okay, so that's why we have a 2 in front of every one of them. What's its period?
Period will be, can't read that,
Yeah,
pi over 6.
It must be pi over 12. Yeah, that's pi over 12. That's pi over 4. That's a third of that. And that's pi over 6. So that's...
pi over 6, period.
Well, let's see. What's the difference between pi over 4 and pi over 12? Yeah, that's 3 pi over 12 is pi over 4. And minus pi over 12 gives you 2 pi over 12 or pi over 6. So that's the period. And if the period is pi over 6, what is B?
B is 3. Or 4. Or no, yeah, it is 3. It is 3.
Hold on. B is going to be pi, not 2 pi. Pi divided by pi over 6.
So, oh, yeah, 6 then.
Okay. So we're looking for negative tangent. That one right there. Okay. What's B?
B will be 4/3.
Well, let's do B first, and then we'll look at for the period.
B will be 3 pi over 4.
Okay. And the period is what divided by 3 pi over 4? Pi divided by 3 pi over 4, which 4/3. Okay. It's pretty generally true that if B has a pi in it, then the period's going to be a number. And if B is a number, then the period is going to be in terms of pi. You know what I'm saying?
Yeah.
Okay. What's the period of g of x compared to the period of f of x? Is it bigger or smaller?
G of x will be bigger.
Okay, by a factor of?
I believe that the answer is D.
Yeah, it's 3 times as long because B is 1/3. So if we were going to figure out the period, it would come out to be 6 pi. And we know the period of that's 2 pi. Okay. Let's see what else.
That's all we got.
What was that?
That's all we got.
Okay. We've done these. Yeah, we did that. I thought maybe we didn't quite get to all of those in the first section. I don't know if we did these bottom set there.
I ended up finishing them.
Oh, you did them already? Okay.
Yeah.
Oh, are you good to go? It seems like you know this pretty good. In fact, the only thing I think that can happen is you can make an accidental mistake, a silly error.
Yeah.
But if I remember right, from last year, that was always the case. In other words, you understood the math of it, and the only mistakes you tend to make were the ones, you know, just not focusing enough on it. But maybe in a test you focus a little bit more. I suspect you do. So I think you're in good shape for this test tomorrow. You feel like you are?
Yeah, I feel.
Yeah, I can't think of any last thing to even tell you. Just remember sine and cosine's natural period is 2 pi and tangent is pi. And that's about the only place you can get tripped up.
All right.
And tangent and secant straddle the y-axis, whereas cotangent and cosecant are between the y-axis and the first asymptote.
So just remember the 2 keys.
All right. Jackson, I will talk to you. We've got a 30-minute session tomorrow night, Tuesday, Wednesday, and Thursday night.
Yeah, I think that should be right.
Okay. I'll talk to you tomorrow night.
All right, later.
Bye-bye.
See ya.